Hi, I'd like to take this opportunity at the end of Statistics 1, first of all, to thank you for sticking through the course and watching all the videos and even this last segment. And I'd also like to take this opportunity to thank the staff working behind the scenes. So I didn't do this by myself. I had a lot of help, and these were the primary people helping me. So I'd just like to introduce you to them. You've seen them or heard from them probably in the discussion forums. And first off, on my far left is Laura Suttle. You probably know her from the wonderful Introduction to R videos that Laura posted in the first couple of weeks that really helped us out in getting people to get R installed and learn and get going in R. Laura does a lot more than that. She's been doing a lot of work for this course, and she works on other courses at the university as well. And she's a fifth-year graduate student in the PhD program in psychology here at Princeton. Next off is David Marot. You probably saw him maybe in week 2, week 3. David is a postdoc working in my lab. He did his PhD at the University of Lille in France, and he will be helping me develop new content for the next iteration of this class. So he's looking very carefully at those forums and all your excellent feedback. We've compiled it, and David's going to be the main man for working on the next iteration. To my right are 3 graduate students who all work in my lab. This is Brooke McNamara, Michael Chow, and Tasha Holden. And they were tasked with watching all the videos. Imagine watching your own advisor on, every week. And they were tasked with watching all the videos and coming up with those in-video quizzes that you took. So they wrote all those. I didn't do that. So thank you for all that work. So this crew is sticking with me, and we're going to revise the content, and hopefully we'll have another course coming up soon. So thank you, and thank you. Hi, and welcome to the final lecture of Statistics 1. And first, let me say thank you for sticking with it and making it all the way to the end. I'm going to keep this last lecture short and just do a brief summary of what we've covered. And in a way, I'll just organize the material for you. If you are trying to take the final exam and study for the final exam, that's great. I'll provide you with sort of a way to organize the material. Of course, you could just look at the course schedule and organize the material just by week. There's 6 weeks, and each week is organized nicely. But I think when you're studying for an exam, or as you're sort of trying to wrap up information from a semester, it's good to organize the content in a couple different ways. So certainly organize it by week. I'm sure you've already done that since that's how it came to you. But I'll show you sort of how I see this material from my perspective, having taught this content in, of course, different formats many times. So when I look at the material and everything we've covered, this is sort of the categories that come to me. And there's 1, 2, 3, 4, 5, 6, 7, 8 categories. That's good. George Miller said we should have 7 plus or minus 2. So I'm still within the range of memory capacity. So one way, organize it by week. That'll give you a nice 6 categories, but you might want to also organize it this way. So we spent a lot of time on experimental design, and that was by design. The very first lecture, right, we talked about the power of randomized controlled experiments. And I'll say more about that in a minute. Then we spent a lot of time on descriptive statistics. We moved to correlation regression, simple regression, correlation regression, they go together. Probably unique to this course, you probably won't see this in many other introductory statistics courses. We spent a good bit of time on measurement. Then, of course, right in the middle, and this was probably the most painful piece for a lot of you, was that big chunk on multiple regression. We spent a lot of time there. And that, to me, is the most complex material we covered, especially mathematically, computationally. We covered the central limit theorem, which is essential in an introductory stats class. I think that provides a lot of insight as to where a lot of these values come from and how to interpret them. We talked about null hypothesis significance testing, the problems inherent in that approach, and we discussed alternatives. And then toward the end of the semester, this last week, we did different kinds of tests to compare means. So let's look at each one of these in a little more detail. So again, there's a big emphasis in this course on experimental design, and you might not see that in some other introductory stats courses, especially courses that are very mathematically driven. Especially in the last few years, there's this push towards what's called big data. It's the idea that you can download lots of data from the internet and do all these fancy analyses. That's all well and good. It's interesting. But to me, what's more interesting, and the approach I take with statistics, is to start with a theory and design an experiment to test that theory. That's what we use in my lab and my colleagues. That's what we use statistics for. The big data approach, it's exciting, but my personal opinion is we need to start from theory and then go to data. Not everyone agrees, especially in this era of big data. Some people say that may take over and trump theory. There are two sides to that argument. So we spent a lot of time right away. Lecture 1, the polio vaccine example, the power of a randomized control experiment. It's the best tool we have to make arguments about causality. And then at the end of the semester, we spent a lot of time looking at randomized controlled experiments in the various kinds of ANOVA designs, right? So we had the one-way between, the factorial between, the one-way within, and the mixed. So there's lots of different kinds of designs you can do. And with all of them, if you're doing randomized controlled experiments, you can just do an ANOVA. Of course, this is an intro stats class, so we covered descriptive statistics. It's almost essential to start there. So I like starting with histograms. You look at the entire distribution. Remember, we did that because if you just rely on summary statistics, you might miss important information. So if you look at the entire distribution, that might reveal something about your experiment or the data that you would miss if you just looked at summary statistics. But of course, summary statistics are handy. If you want to make a point quickly, you need some sort of talking point. Calculate summary statistics, the mean, the variance, the skew, the kurtosis. We then move to correlation and regression. Those go hand in hand, right? If two variables are correlated, then I can use one to predict the other. And that's the point of regression. So that's pretty easy. As I said, we then spent probably more time than any other intro stats course would spend on the measurement of constructs. And that's because I come from a psychology background. This is really my area of expertise. This is what I do in my research. I study individual differences in intelligence and working memory. Those are sort of fuzzy constructs. They're hard to measure. So I have to be very careful about measurement. So I've spent a lot of my career worrying about issues like reliability and validity of measures and constructs. So that was a big piece of this. This was probably the biggest chunk to you. That's what it felt like looking at the forums. There's a lot there. And I'm not sure if I'll cover this much multiple regression the next time I do this course online. I do this live because these sorts of things are easier to talk about when you can have a dialogue. Particularly mediation and moderation, and the interpretation of regression coefficients in those kinds of designs. And matrix algebra, that was not an easy lecture. That was pretty weighty. So thank you for sticking with that. Again, this is pretty advanced stuff. You don't typically see that in an intro course either. I actually told some of my colleagues in computer science here at Princeton that I covered this in a 6-week intro course, and they gasped. They were really impressed that we got that far, so thumbs up. As I said, we got to the central limit theorem. You got to get there. That's really a core piece of intro stats because it illustrates the importance of sampling, the importance of sampling error, and the concept of standard error. It's core to the beginning of inferential statistics. We addressed null hypothesis significance testing. We pointed out the many flaws. Of course, it's biased by n. There's logical flaws. Who would predict nothing to happen, right? There's all sorts of problems. The two alternatives that I like the most are report effect sizes. So, okay, it's biased by n, so follow it up with estimates of effect size. If you're doing t-test, Cohen's d. If you're doing ANOVAs, eta squared. If you're doing multiple regression, standardized regression coefficient, or model R squared. Which leads me to model comparison. That's my other way out of NHST, my preferred way out, is engage in model comparison. Any good experiment or any good study is designed in a way that it can provide evidence for theory A and against theory B. It's not enough to just provide evidence for theory A and against the null. That's not very impressive. You should be able to design a study so that you can, provide evidence in support of one theory and reject another. And by doing model comparisons, you can do that. And finally, at the end of the course, we did several tests that are just really common in statistics. You're welcome, my brother Mike. He was really looking forward to the t-tests because he does them all the time at work and he didn't know how they work. So I hope you know now, Mike. And thanks for sticking through the course. So t-tests and ANOVA, they're really common because we find ourselves in that situation often where we just have to compare means. And the way to do that is through t-tests, if you're doing just comparing two means, if they're two different groups, independent, same groups, dependent. More than two, do an ANOVA. What form of ANOVA depends on the design. So that's the end of the lecture. But I want to say thank you to the students, especially those of you who have stuck with it, especially after those first couple of weeks we had a rough start. So thank you for your patience. This is, as we've said over and over on the discussion forums, this is the first time for everybody. We really appreciate the feedback that we received on those forums. You have given us our to-do list for how to improve this course so we can launch it again on Coursera, hopefully soon. So stay tuned. My lab group and I are working on Statistics 1 2.0, and we'll use a lot of the feedback that you gave us to make it better. It will be coming soon to an electronic device near you.